Hi, my name is Katie, and I am the driver for the station, and I'm here with.
Hey, this is Lindo. I'll be the navigator for the session.
Okay, so today we are covering chapter 4, where we are just connecting to MongoDB. So basically, it's just going to list all the ingredients. Let me just expand the screen. Yeah, it's just going to list all the ingredients by the unique ID, the name, the type, and as well as the class. Next, here we have our taco order. So when you place an order, MongoDB will capture it. As you can see, there is a unique ID, the date and the time when it was placed, as well as the delivery name, delivery street, delivery city, delivery state, delivery zip, CC number, CC expiration, CVV, the tacos array, telling you the name when it was created, and the object, basically. So that's all. So also just to cover what we were introduced to in this chapter, we were introduced to something called Cassandra. Okay. So Cassandra is a highly scalable distributed NoSQL database designed to handle large amount of data across many servers with no single point of failure. It's known for high availability. Even if some nodes go down, the system keeps running. It's fast writes, ideal for applications that need to log or ingest data quickly. Decentralized architecture, no master node, all nodes are equal. Wide column storage stores data in rows with flexible columns, are great for time series and big data. Now, I'm going to start with our files just to explain how it's all connecting together to get to MongoDB. And that's like basically it. So here we have the ingredient by ID converter. So this is a string component that converts a string ID into an ingredient object. This is useful for binding form data, which is ingredients, IDs from the checkbox, and to ingredient instance during the request handling. So here we have the private ingredient repository. This is the repository used to fetch ingredient entity from the database. Next, we have our at auto wired. So here we have a constructor injection of the ingredient repository. Spring will automatically wire the repository bean, and here the repository is just used to look up an ingredient by the ID. And then lastly, we have the override ingredient convert. This is just going to convert a string ID into an ingredient object. The return null. Then it will return null if no matching ingredient is found. Then we have the params ID, the ID of the ingredient to retrieve, and the return, which is the ingredient object, or null if it's not found. Moving on to our next file, we have the order controller. So basically, it's just going to handle all the web requests related to placing a taco order, and it uses Spring MVC annotations to map the submissions and manage the session date. So this is just going to keep the order in session across multiple requests. Here we have our private order repository. So this is just a Spring Data MongoDB repository for persisting taco order documents. Next, we have our get mapping. So over here, it's going to display the order form to the user, and then it's going to map to get order current. Next, we have our post mapping. So it's going to process the submitted taco order, and if validation passes, it's going to save the order to MongoDB and clear the session. So the MongoDB behavior automatically serializes the taco order into a Python document. It stores it in the configured orders collection, generates any unique ID field if not already present, and it handles the nested objects, for example, the tacos of the ingredients as embedded documents of reference. Um, so the param order is the validated taco order from the form. The param errors is the validation errors if any occur basically. And then we have the session status. It is used to clear the session after a successful submission, and then the return is just going to redirect the user to the home page or display a form error. Moving on, we have our next file. So here we have the document tackle order. Let me just highlight it. So this is just going to represent the custom tackle order. This class is mapped to MongoDB document in the tackle order collection, and this just includes the delivery details, payment information, and the list of cycles. So MongoDB will store this document in the tackle order collection like I have displayed earlier. The private string ID, MongoDB will auto-generate the ID if it is not set. The private date place date is the timestamp for when the order was created. And then here we just have the delivery information with the validation constraints. So I've already explained this, but I'll go over it again. Um, Here we have the not blank by each one, so it's just going to make sure that none of the information blocks have been left blank. So we are required to give a delivery name. We're required to give a delivery street, a delivery city, a delivery state, a delivery zip. The correct a correct valid credit card number. The correct format for when the expiration date or is of the credit card, and then the CVV digits that must be valid as well. And then this will just place the taco order to the tacos. So this will just give the taco order. Basically, it's just going to edit. And then moving on, we have the taco Java. So it's going. This file just represents a single taco design submitted by the user. This class is stored in a MongoDB document in the taco collection, and it also includes the taco name, creation timestamp, and a list of selected ingredients. So here we have the document collection. This explicitly maps this class to the taco collection in the MongoDB. Here we have the private string ID. This is the ID MongoDB will auto-generate if one is not set. Here we just have a not null again for the name. So the characters for the name has to be, wait, is it name? Not, yeah, for the name it has to be at least 5 characters long. This is just a timestamp when the taco was created. Also here we must include at least one ingredient and then store, and then it's going to be stored and embedded in the MongoDB document. And then this is just going to add an ingredient to the taco, and MongoDB will serialize each ingredient as part of the ingredients array. Um, right. So here is the taco order, the time when it was placed, the timestamp, as well as all the information needed for the taco order to go through. And then lastly, we have our last application, which is the taco cloud application. So this is just the entry point for the Docker Cloud Spring Boot application. It automatically configures Spring components and starts the embedded server. Okay, so if you take a look over here, this is just going to preload the MongoDB database with a set of predefined ingredients. The bean runs once the application starts. And then MongoDB behavior. So each ingredient is serialized into the Python document and it's stored in the ingredient collection based on the add document annotation in the ingredient class. So if an ingredient with the same ID already exists, it will be overwritten. Then the ID fields are set manually using the constructor, which is like this, these. basically, the IDs, I guess. And then the param repo, the ingredient repository, is just used to process the ingredient documents, and then the return command line runner. This is just going to insert the initial data. And that is it for chapter 4. Thank you for watching.